Hello?
Thanks for waiting, Jason. I'm sorry. My
Yeah,
internet connection is like, it's raining a lot here where I'm at, and I think that has something to do with it. But I'm not sure. I'm gonna hang out here till 12:30. So if you want to stay a little bit over, you can.
that's
Professor
fine. I need the extra help.
Professor Nick Dell is running late too, so there may be some people from her office out. No, I'll stick around for a while and help you. Because it's not your fault.
Yeah.
All right, so we were in the middle of doing the data. Did you do, let me pull it up. Let me pull up the data for the problem we were doing. You have to put in the data like before, okay? The good news is we don't have to do the z-score because it's one we already know. It's for 95. And that's for one that she had given you before. You can if you want, but 95 is a common one. So we're going to do the same thing. We're going to take our, let me see if I can do this here. We're going to take our data. We're going to take our calculator. We're going to put our data into the calculator, which I'm going to see if I can make this work here. Yeah, that should be good, except I need to move this over. And I'm going to see if I can share the screen here. Maybe I can do it like this. I think I might have figured out something. Can you see both? Can you see?
Yes.
Oh, yay, I figured that out. Okay. So I didn't figure out the way Zoom was telling me, but I think I figured it out how to do it. All right. So what we're going to do is we're going to go ahead and enter the data. Okay. So
I already did.
you did already? Okay. I trust you. What did you get? Tell me.
For the X, I got 58.17142.852.
4, 2. Okay. We can just go with 4 places probably. 58.1714. That works. And so we're doing it with 95% confidence. When it's 95% confidence, we know from before when we were doing it in chapter 6 where she gave you the z's, that z is 1.96. Okay. If you want to remember why, let me remind you here, because it, like I said, it's been a minute. We have our normal distribution, right? And we have 2 sides. And we have 96 in the middle, right? And remember, we know how to get the complement. So this is 1 minus 0.96. That's 0.04, right? Now, this is the area in both tails. We don't want that. We want the area in a single tail. So we're going to take 0.04 and divide that by 2, okay? 0.04 divided by 2. And that's going to give us 0.02. So far, so good?
Yep.
And then we're going to do inverse norm of, now remember, this is 0.02 over here. And when I do the inverse norm of it, I have to use everything to the left. So we're going to use second distribution, inverse norm right here. This is going to be 0.98 this time. The 96 plus the 2%. So this is 98. We're going to paste it. We're going to get that. And we're going to get, oh, I see. I'm glad I did it because I was wrong. This is, oh, wait, it's supposed to be you know what? I made an error. It's 95% confidence. So I got to do my calculation over again. It should be 1.96. That's why I'm looking at it like it's suspect. This should be 95. So this is going to be, this calculation is going to be 0.25. I'll show you that in a minute. This is, this answer was wrong. Let me fix that. So this is 0.025 because this is 95, which means that this is going to be 5, not 6, right? So half of 5 is 2.5, which means this should be 5% here, not 4. This is 5%. So 5% divided by 2 is 2.5%. And that's where we get, see if I can do this correctly this time. Inverse norm, let me see, mouse. Okay. Second distribution, inverse norm, right here. We're going to use 0.975, not 98, 975. We hit enter and we get.
Wait, 0.975?
Because remember, 95 is the middle, right? And I need the air, all of the area to the left. So 95 is only the area from here to here. Okay. It's not this tail piece, and I need the tail piece. I need that tail, right? So this is going to be 97.5. My Z is going to be 1.96. You already gave me my mean.
You should be 1.95.
I'm sorry?
1.95.
1.9. It actually rounds because there's a 9 after it. So that's going to be 1.96, right?
Okay. Wait,
So,
how did you get 975 again?
okay, so we're doing 95% confidence, right? 95 is in the middle. 1 minus 0.95 is 0.05, right?
Okay.
So what I did was, I did this. I said, this is, let me move this up so I can put the calculator there. 1 point.
Oh, I see it now.
1 minus.
You added it.
Yes, I added 95 and 0.025 together. Okay. Yeah, okay. So now we should be ready. We should be ready to now remember, she gave you the sigma. It's 6.46. So we have that also. Sigma is 6.46. Okay. So now we can construct our interval. Let me erase this part so I can stay on the calculator screen and bring up the numbers. I'm going to actually, I think what I'm going to do is go ahead and
And we're
hide that
only
for a minute.
using are we using the 4 digits?
We're using the 4, all right, we're using the 4 digits at the answer. So here we're using 2 for the Z. So what we're using is, let me show you. What we're using here is we know that Z is, all right, I'm up in here. This is 1.9, whoops. 1.96 1.96. We're using the sigma is the one in the problem, which is 6.46, I think. Is that right?
Yeah.
The population standard deviation, right? This is 6.46. And this one, we know that how big was your sample size? How many numbers did you have?
35.
35 numbers, okay. 35 numbers. And we know that our mean, because you gave that to me earlier, was 58.1714. So X bar here, the mean is 58.1714. Okay. Now we just do what we did before. Okay, so what I'm going to do, I'll do it here on the side. You're going to do let's do the error term first, because that makes it easier on the calculator to do this. The error term is, remember, it's the z value, right, times my sigma over the square root of n. Okay, so in this case, my error term will be in, whoops. So this is going to be in here, right? Come on, pen. There we go. All right, good enough. This is going to be, let me see. So we have 1.96 times my sigma, which is 6.46, divided by the square root of 35. And if I calculate that, that gives me this number, 2.1402 and some change, right? And what I'm going to do is I'm going to take my mean, which is 58.1714, and subtract my error term from it, giving me 56.0312, because this is 119, so 12, 56.0312. And my other answer is going to be 58.1714 plus, I'm going to add it on, 2.14. So this is going to give me 60.3116. Okay.
Are we using the 4 digits?
I believe so. Let me check to see. Do I still have that open? Let me check. I don't know.
Nope, we're using the last. We're using the first.
You're using the 3 digits? Let me check that.
Because the answer key says 56.1.
Oh, okay, so she just used, that's interesting that she just used 1 decimal. Yeah, here she has, oh wait, this is not the right one. I was looking at the right, okay. I have, okay, that's that one. Where is the other one? Where's my other raw data? Give me A moment. Find it. I think this one here, is this it? Yeah, so she has, here she has, okay, so she has the 1.96 as her Z. Let me bring it up so we can look. So her answer key seems to be, she seems to have rounded differently from when she made, she'll tell you on the quiz what she wants you to round. Yeah, so the mean is 58.1714. Good. We got all that. We did the calculation. We got 2.1402. Yeah, so she rounded her final answer to 4. 56.0312 and 60.3116. Okay.
Uh-huh.
It's less work if you don't have raw data. If she gives you all these values already, all you do is plug it straight in. But when you have raw data, you need to get the mean and the sometimes the standard deviation first. Okay. Let's go to the next one. Number 9. Okay. Let me make sure that I'm sharing the correct screen with you. Let's do this here. Okay. So I have number 9 says a study of 415 randomly selected kindergarten students showed that they have an average of 5,000 hours, wow, of television. They're in kindergarten. My goodness. N is 415. And they have an average, a sample mean of 5,000 hours. Says if the sample standard, okay, so they give you the sample standard deviation here is 900. So we're gonna use 900 for that. Find the 95% confidence interval for the mean of all students. Okay, so we find the interval, and then it asks us a question. It says, if a father claimed that his children watched 4,000 hours, would the claim be believable? Well, let's see. Okay. So here this actually is a lot less work because we just plug in the numbers that we have. So we're going to plug in our numbers. I'm going to move this over and share the screen again. But I'm going to move this up so we can see what we're doing. And whoops, that's not the right screen. Hold on, let me share. Where's my calculator screen? There it is. And where's the homework screen? There. Okay. So I'm going to drag this tab over here. So basically we have everything that we need. Let me bring up the calculator here. And then I'll share both screens with you as soon as I make this smaller. Okay, so we've got that screen there. Just get this a little bit smaller. Let me see. Where's my numbers? Homework screen. Okay. So we have So this is going to be, let me clear and let me share the screen with you. So here we have, here's my
oh,
screen. There it is. So here we know that, let me put some things in the
I already know what the mean is.
box. Yeah, they told you, right?
5,000.
5,000, right? What else did they tell you?
The standard deviation,
Which is
900.
900, good.
And 415 were randomly selected of kindergarten students.
Right, very nice. So, and what do you know about your Z?
It's fine, 95%.
95, and we did 95 just a problem ago. What was our Z there?
95, oh, 5.05.
Right, but what was our Z score?
Z-score. I always forget the Z-score.
We did it. I promise you. We did it. 95. Remember, there's 5% in both tails. So we split half, right? And we did the inverse norm. What did we get when we did the inverse norm? Do you remember?
0.196.
1.96, right? So in this case, all we're doing, we're going to calculate the error term, right? For all those values that you just gave me. So we're going to say this. We're going to say, we're actually going to make this bigger so that we can see the whole screen. Okay. 1.96 by Z times.
Wait, is there a 1.96 right here?
That I'm using it from the last problem, but the way we get it, remember, is we're 95% confident. Remember this?
Oh, yeah.
Remember that? So
Yep.
do you need me to go through it again or not?
Nope.
No, you're okay?
Yep.
Okay, so 1.96, remember, we're using this formula here. So Z is equal to, E error is equal to Z times sigma over the square root of N, right? Only this time we're using S in place of sigma, right? So 1.96, your S was 900, you said?
Yes.
Good. So let me
That's a
see.
standard deviation.
900 divided by the square root of?
Square root of 415.
Perfect, yes. 415. That's my error, remember. That's not my interval yet. But we're on our way. So this is equal to 86.5914. Okay. Now my mean is 5,000 hours. 5,000.
86.4?
86.5914.
Oh.
5914. Right? Because it's 59135. So you can use just those 4 digits if you like. So this is 86.5914 for that. And that's your lower. So your lower one is 4,913.4086. And your upper one is 5,000 plus this, which is 5,086.5914. Okay.
Mm-hmm.
So there's my interval. Now the question was, if somebody told me, if the father of one of those kids told me, well, my child's only watched 4,000 hours, right?
Mm-hmm.
What would you tend to say about that claim? What do you think? Do you think that claim is valid, or would you be skeptical about it?
Valid.
Why do you think it's valid, Jason? Tell me why.
I don't know.
Well, what does the confidence interval tell us? The one that we just calculated.
At I don't know.
Okay, well, that it's good that we answer this question, because sometimes we get into calculating and we don't really know what they mean. What this means, this is a 95% confidence. So what this means is this. This is, you don't have to write this statement down, but I'm writing this for you and for people who watch this in the future. We are 95% confident. Okay. We are 95% confident that if we repeated this similar procedure over and over again with different samples, right, that the population mean, okay, the population mean is of, and I'm going to describe it, of hours of television watched by the kids, watched by the children, right, is between 4,913.4086 hours and 5,086.5914 hours. Okay. We're confident that the population mean is somewhere there, right? Now, where is 4,000 in that? If this is 4,912.4086 on the left, and the right side is 4,912.4086. Sorry, I wrote the same thing twice. 5,086.5914, right? 4,000 is over in the tail, isn't it?
Yep.
So think about this. This is your confidence interval over here, right? From here to 5,000, and let me keep extending this out because this is not happening for me. But we're over here. 4,000 is somewhere over here, right? Like way over here. So is that very likely?
Yes.
Is it?
Oh, no.
This tiny little portion isn't, because remember, we've got 95% over here, right?
Yep.
And this little tail, there's not much left in here, right? This tail is only 2.5 anyway. So if somebody said to me, well, my kids only watched 4,000 hours, I would tend to be very skeptical, of that claim. So to answer that question, you can say, I would be skeptical of a claim that the mean was 4,000 hours, something like that. Because, I mean, you could have a sample that was biased, but it's not very like, you're 95% confident that you fall within those two numbers. Okay, so that's what's going on there. Let's see if you can do the next one. I don't think the next one has any raw data, so I think we're okay. Let's take a look at the next one and see how it is. Number 10. Is that where we are? Let me make sure that I'm okay. Now drag this over so we can see what we're looking at. Okay. Number 10. Noise levels. Oops, are you here?
Yes.
Did I lose you? Oh, no. Mauricio's here. Okay. Go ahead and read number 10 for me, Jason, while we're waiting.
Hold on.
Hey, Mauricio, can you hear me? Let me see if did we lose him in the waiting room? Maybe not. Oh, he's joining, but he hasn't joined yet. It says he's joining, but he's having some issues. Okay, while we're waiting for that, number 10. Noise levels at various urban hospitals were measured in decibels. The mean of the noise levels is 84 reflected corridors was 61.2 decibels, and the standard deviation of the population was 7.9. Find the 95% confidence interval of the true mean. I think you can do this one. I'll help you if you need it, but I think you can do this one. Okay. It's just like the last one, but with different numbers. Okay. What is your mean here?
The mean is 84.
And the standard deviation?
70.79.
7.9. Okay.
Yeah, 7.9.
And your sample size is how much?
84.
Good. And what are you going to use for Z?
95.
95% confidence, but what is your Z?
4,000 hours.
No. I want to know what your Z is. What did we use for Z last time?
1 minus 0.95.
Okay, but after we did that calculation, what did we get for the Z score?
.05.
No, okay. I'll have to derive it for you. It's 1.96. It's 1.96, Jason. The Z is 1.96. The confidence level is 95%. Okay, you're confusing the names of those two.
How did I get 1.96 again?
Okay, so hey Mauricio, can you hear me?
Yeah, can you hear me?
Yeah, we can.
Okay,
we could hear you. We could hear you, and then we lost you. So we were like, let me hang out. I'm gonna hang out here for a while because I was having some issues with my internet earlier. So if you were trying to join earlier,
yeah, you know what? I think my computer or something. It's like I'm on my phone right now talking to you on Zoom. So maybe something's wrong with my computer or the internet from there. But go ahead. I'm with the other student.
We're working on 7.1 right now, so I don't know if that's what your question was on.
No, but I'll stay until you can help me out with 7.2.
Yeah, I'll stick around and help you.
Okay.
So
Okay. I got
Go ahead.
1.96.
You got it to work? You need me to show
Yes,
you again, or you remember, Jason?
I remember now.
Okay, try working on number 10, okay? And see if you get an answer that matches. I'll hang out for a while, okay? So don't worry. And also, I think Professor Nickdell is available as well if you needed to speak to her. I think she's in her office if you had any questions that needed to go to her. Let me bring up, while I'm here, let me bring up 7.2. Give me, I'm gonna stop sharing 7.1 because 7.2 I don't have up right now. What's the deal with 7.2, Mauricio? Did you find a mistake?
Not that I found a mistake, but I'm finding out how do you get the T values.
Oh, the T values. For that, you have to use the inverse T in your calculator. So let me,
Can you show me? Because I kind of
of
figured
course.
on 7.1, I think the other one how to get the wherever I have my paperwork, but I figured out how to do that. But this one, I took a while, and I'm like, you know what? I'd rather talk to Shauna or maybe the,
Yeah, no worries. We can show you that. Let me see if I can, if it didn't log me out again, which it might have done, because it's been that kind of day this morning. Yeah, let me show you how that works. Okay, when we're in statistics, let me grab that. And you said you're having issues with the T's. Let me see. That's weird. Why is it not showing me the modules? I don't know. But let me, pages, immersive reader. Okay, let me do what I did before and hit start and go to this, because this is not, there's something wrong with the way Canvas is. There's something wrong right now with my Canvas display, so I don't know if you guys are having that problem as well, but I'm having to kind of backdoor this through through my faculty access. So if you guys are having problems, let us know. I'm gonna let her know as well, because I don't know if they're doing maintenance on it or if it's just a glitch, but it's been happening to me since about an hour before the meeting started.
okay, well, I know yesterday I was trying to Zoom one of my professors, and it just kind of froze on me, but I don't know, it's probably something completely different.
Well, the Zoom is being, right now I have you connected to my hotspot, or who knows where I would be in the middle of the because, all right, 7.2 confidence interval, there's PowerPoint. We don't want the PowerPoint, we want the homework. So let me go to the next page and see if the next page is up. Okay, yeah, so here's, I'm going to show you this first, because there is a page on it and I'm not sure if you're aware.
Okay, I did see that page. Let me see.
But she does give you some.
I do see it, but the distribution table, right? Table F.
Right, and she gives you the confidence coefficients and table F right here. Okay. There is also when you're doing the inverses though, you're gonna have to go into the calculator for that. So let me download the homework and see what we have here. See if that's gonna, but you were having trouble with the tables, you said?
Well, I'm trying to figure out how to get the answer, like from the values of each, like 18 for 99% confidence
Oh,
interval for
yeah,
the.
you won't. Okay, so from the tables, you won't be able to get an exact answer because they aren't exact enough.
Okay.
That you have to use the calculator for that, and I can show you that.
Okay.
Which one were you trying to work on?
I think it was number 2. Just
Number 2?
just learn how to get
Yeah.
at least that one answer.
Yeah,
correct.
definitely, not a problem. So here, find the values for each z or t of alpha 2 and n equal to 18 for the 95% confidence interval. Okay,
Okay.
so 99. So what we're gonna do here, I'm gonna do a little drawing on the side, and this is the same procedure that you can use for the Z if you need to. There'll probably be at least one question, maybe not on the quiz, but on the exam about this. So you should know how to do this if you need to. Okay. If you're doing 99% for the T's, okay, this same procedure applies for the Z's to a certain degree. The confidence level is in the middle of the distribution. That's called the body of your distribution. So this is 99 here, okay? This is 99 here. Now what you're gonna do is you're gonna subtract it. So you're gonna get 1 minus 0.99, okay? And you can do some of this in your head. If you could do it in your head, that's fine. But I'm going to show it here. This is 0.01, okay? This is the area in both together, both tails together, all right? So we need to split this in half. So this is 0.01 divided by 2, which is 0.005, okay? So now this is going to be, now when we get the confidence coefficients, okay, we're only looking for the positive portion of this, all right? So we want the area to the left, which is going to be 0.995, okay? Because this is point. So when you go to your calculator, let me share the calculator screen.
Okay.
We're going now here, we're going to do something similar to what we did with the normal distributions. We're going to use our inverse function. Your calculator should have an inverse t function. So the way to find it is to go to second distribution, go to something that says inverse t, INVT, inverse t.
4.
Number 4. It should be, for me, it's below inverse norm.
Okay.
Do you have that?
I should have it.
Second distribution, which is on top of the vars key. And then for me, it's the 4th option, number 4. Yours might be number 5. Some calculators have an extra option there. Inverse t, and when you hit inverse t, it looks like this. Area, degree of freedom.
I'm there.
Okay, so if you don't want to do all the math that I just did, you can put in the 1 minus alpha divided by 2, which your alpha was
99.
0.01.
Okay, 0.
Divided by 2. Okay, I just wanted to show you where the numbers were coming from. Okay, now remember this, because this is something that's small, but it's tricky for some students. Your degree of freedom is n minus 1. Okay, she gave you n, so your degree of freedom is actually 1 less. So your degree of freedom here is n minus 1, and that's always true about the t's for this section. So this is n minus 1. So if n is 18, then n minus 1 would be 17 here. So you're going to put 17 in your calculator,
Okay.
and then we're going to paste it. And we're going to get 2.8982.
Oh, wow. Nice. Okay. At least I know how to do that.
Okay. Yeah. So the tables can only provide you with estimates. So that's one place where the tables won't work.
Yeah, I can see that when you got like 9.95, you like you really don't have 9.96 and stuff like that. Something like that.
Yeah. So those, it'll work for the Z's because they have all the intermediate, but it won't work for the T's.
Got it. Okay, Shauna, that's pretty much it. If I have any other questions on this homework, I'll probably talk to you tomorrow. I know you're.
Yeah, definitely. And if you guys need a little extra help tomorrow, let me know, because I can open up the meeting on Thursday. I can open it a little bit early if I have to.
Okay, well, thank you so much, Shauna. Like always, have a nice day.
All right, take care, Mauricio.
Bye.
How are you doing, Jason?
I already did the answer.
Did it work?
Yeah, I just
Good.
mixed up the mean with the n.
Oh, with the samples. Okay. Are you working on number 11?
Yep.
Good deal. Good deal. Why don't you continue working on that? I'm going to hang out here. I won't leave you, but I'm going to hang out for a minute.
Okay.
I'm going to make sure that Professor Nickdell is in her office in case, because I told her I would stay. I'm going to turn on my, other thing I'm going to do is turn on my camera temporarily, because I'm going to have to mute my mic for a minute. But I'm here. I'm going to mute my mic and I'll be right back, Jason, okay?
All right.
How are you doing, Jason?
Number 12 is confusing.
Number 12, let's take a look at it. You were doing so well. I hope I didn't jinx you.
It says
All right.
assume ounces at the end, and it doesn't even have a
Oh,
specific ounce.
oh no. Let's take a look. Maybe it's, yeah, I told her there were some inconsistencies, so she's gonna call me and we're gonna see about it. 12, you
Yeah,
said?
because I'm pretty sure if this doesn't get fixed, a lot of other kids are probably gonna have trouble. And the quiz is tomorrow.
No, don't worry, we'll fix it. A healthcare professional wishes to estimate, okay, all right, 12 and 13 are not confidence intervals. 12 and 13 are sample sizes. This is the
Uh-huh.
sample size calculation, all right? So it's a little bit different. Now, yeah, I agree with you. I'm not sure why assume ounces is a period. I don't know that. But this is a sample size calculation. It's not a confidence interval, okay? So when you, let me show you this because I don't know. Did you see the sample size formula when you were studying or not? Have you seen it?
No.
Okay, all right, that's probably part of it. Let me take a look. Let me show you what this is so you can see what we're talking about. Okay. And Professor Nickdell does know about the problems with our Canvas and our phone. She says they're working on it right now. So that might be part of the reason why we were having some of the problems that we were having with our connection stuff. So we'll have to see. Let me pull up this for you so you can see what I'm talking about. Okay, so we've been doing confidence intervals, right? And then at the end of this, we have sample size calculation. And this is what we're talking about. N, our sample size, is equal to our Z times our sigma over our E squared, okay? Now, in here, this is really important. A lot of times you'll get a decimal number, okay? But this is a sample size. So your sample size should be a whole number, okay? So if you get a decimal at the end, you're gonna round it up to the whole number, all right? So let me show you an example of this. It is desired to estimate the mean number of chocolate chips per cookie for a national brand. How many cookies would have to be sampled to estimate the true mean number of chips per cookie within 2 with 95% confidence? Assume that sigma is 10.1. Let's go to the, so this within, however much the within is, within 2 chips or whatever, that's your E. Okay, so they're giving you E here. So let's go to this problem that you were looking at, and let's see if we can figure it out. A healthcare professional wishes to estimate the birth weights of infants. How large a sample must be obtained if she desires to be 90% confident that the true mean is within 2 ounces of the sample? Yeah, you needed a sigma, you don't have it. I'll have to look it up and see what, skip that one for a minute. Skip 12 for a minute because I'm going to have to go look up what sigma was supposed to be. You need sigma for this and you don't have that. 13 says if the variance of a national accounting examination is 900. Now, this is not as missing as it looks. She just gave it to you in a different way. variance is the standard deviation squared. Okay, so variance is sigma squared. So if variance is 900, right? What does that tell you about the standard deviation? How would I find what sigma is?
Mm. Say it again.
Sure. If variance is sigma squared, right?
Mm-hmm.
And variance is 900, how do I find out what sigma would be?
Um, 900 over 2. 900 to the 2 of a power.
How about square root
Yeah,
of 900, right?
yeah.
What's the square root of 900?
30.
Yeah, so sigma here is 30, okay? So we know that sigma is 30. She gave it to you, but she gave it to you indirectly. Sigma is 30, right? My error here, remember I said go with the within, right? Within right here. This is my error. So my error here is 5. She gave me my error. My error is 5. And the other thing I need is my Z, right? And that I get from my percentage, but I get it indirectly from there, right? So remember my Z, let's practice deriving it so we can practice, okay? So here's my interval. 99 is in the middle of it, right? So I need to find this area, right? So you can either do the math in your head. This is where I got it from. 1 minus 0.99 is 0.01. Okay.
Got it.
Take 0.01 divided by 2. You get 0.005. Does that look familiar?
A little. And then
0.005.
inverse norm.
Inverse norm of 0.995, right? So you're going to do, let me,
Wait, 0.995.
because I'm looking for the positive version, right? You could do the negative and just change it because they're symmetrical. But
Oh,
this is going to be, so when you put this in, this is going to be this. This is going to be, let me get the mouse here. So second distribution. This is second distribution. Inverse norm right here. I mean, yeah, inverse norm, right? You can put it in 1 minus, you can put the whole thing in there. 1 minus alpha, which is 0.01 in this case, right? Divided by 2. And if you do that, you get 2.58 as your Z. Okay.
okay.
You need me to go over that?
What do we do with the 0.995 then?
Well, this answer, second distribution, this answer here is 0.995.
Oh,
I'm saying you can either put that, or you can put, if you don't want to do the calculation, you can put the whole expression in there. You know what I mean?
Mm-hmm.
If you want to put, 0.995 in here, oops, you can do so. This is 0.995 and paste it. Same thing.
Oh.
Okay.
Mm-hmm. What does it equal?
2.58. Okay.
Uh-huh.
So now to calculate your n, you're going to do this. You're going to say that n is equal to n here is equal to my z, which is, I'll write the formula. It's z sigma over e, my error. And I didn't mean to make that as large as it looks. It just, my pen is acting kind of strange. Square. Okay. So your z here is, this is going to be, let's see, this is going to be, where my mouse, this is going to be 2.58 times your sigma, which we said was 30, right?
Mm-hmm.
So we have 2.58 times 30. And we're going to get, oops, times 30. And we're going to divide that by my error term, which is, was it 5? Is that what this was?
Yes.
So we have 5 there. And then this is going to be squared.
Mm-hmm.
Now, this comes out to be a decimal number, right? But this is a sample size. You'll never have a sample size that has a decimal number. So you always take this up to a whole number. So this would be 240. Okay. You always take that up number. Okay.
I
Now
got it.
let me look back at I have to go back to the and give you the number for number 11 because you're missing a number. So let me find
I
the
think it's
missing
8.
8. Okay.
Because I looked it up and it
In the
got the
book.
same. Well, sort of.
Mhm. Okay. I'll take, if you got the same answer, then it must be that, but I have to flag it for her regardless. Okay. I'll
Mm-hmm.
be talking to her later. So as soon as I do that, then I will ask her to change that because I don't have access to go in and change. I can go in and see the assignments, but I can't change them because they only give people with instructors accounts that, and I have like an assistant. So I can't go in and do that, but I'll make sure that she does that. Okay.
Uh-huh.
All right, Jason. Well, it was good to see you. Thanks for your patience today. I know today was a pain.
Mm-hmm.
And I'm
As well,
sorry.
since our time is over, I do have some questions about 7.2 since we didn't get
7.2.
yeah.
Did you start working on it yet?
No, not yet.
Okay. Well, I'll be, if you want to email me, I'll be available until about 3:30 today. So I'll check my email after lunch. I'm gonna hit my lunch right now. And after lunch, I'll check my email. So if you have questions about 7.2, especially if you find any errors in there, email us right away so we can fix that. Okay. And I'll send you some help with 7.2. What kind of questions did you have about 7.2?
Probably like all of them.
Oh, like how? Okay. Well, what I can do is I can send you, how would it be if I sent you some solutions so you could compare her solutions to your work? How would that be? Would that work?
That'll be fine.
That would work for you? Okay,
Yep.
give me about, let's see, it's what time now? 12, it's almost 1. Give me until about, say, 2 or so. And I should be able to get, I'll try to send it to your Canvas inbox. If not, if there's something going on with Canvas, I have your email from when you emailed me before, and I'll send it there. Okay?
Sure thing. Thank you.
You're welcome, Jason. Thanks. I appreciate your hard work. Okay? Take care.
All right. Thank you. Bye.
Bye. I'll send you some.